A lot of people think that computer scientists kind of sit around alone and write code. I haven't written a line of code for like 20 years. I basically spend my entire day writing emails and meeting with people.
Hey everyone, welcome back to the STEMPOWER podcast. Our guest for this week's episode is Professor Kevin Leyton-Brown from the University of British Columbia. He specializes in computer science, specifically algorithmic game theory, and empirical algorithmics and machine learning. So, welcome to the podcast.
Thanks for having me.
Before we start, is there anything you would like to add to anything we just said?
No, it sounds good. Maybe I would include that it's all under the umbrella of artificial intelligence.
Okay, we're going to start off with some general questions before talking more specifically about your work, and then we'll finish off with some more general questions, this time allowing for advice that you can give to high school students. Does that sound okay?
Sounds great.
Okay. So our first question is, what were some career paths your younger self considered?
Well, when I was in high school, I guess I was actually really interested in philosophy. I really enjoyed kind of history and philosophy. And trying to understand how people's minds worked, understand what was important in life, and how philosophers had thought about this for a long time. Really enjoyed it. I actually did a minor in philosophy as an undergrad, but I kind of had a realization that really changed my career and might be useful to some of your listeners, which is I discovered I really enjoyed learning about philosophy, and I still enjoy learning about philosophy. But I don't enjoy doing philosophy. I don't enjoy the kinds of things that philosophers get to do day in and day out, as professionals in 2021 in the world today. On the other hand, I really enjoy what computer scientists get to do, because part of that is computer science is a growing field. It's important to the economy. There's lots of exciting opportunities. There's lots of problems that all of a sudden computer science can make an impact on that are just suddenly available to be tackled. Partly it's big problems in philosophy are hard to make headway on. So there's not, you have to work on some very small piece. It becomes very technical. And partly it's about resources that, if you're working in computer science right now, people will throw resources at you to do what you're doing. If you're working in philosophy, you have to really struggle and fight to get the resources that you need to do what you want to do. And putting all of that together, I decided, I should really do something that I'm going to enjoy doing and not just do something that I enjoy thinking about. And I think that that worked out really well.
I see. Yeah, for sure. I think a lot of high school students have an idea of what they want to do, but they don't actually know how to put that into practice day to day, and that might look a bit different than what they originally imagined.
Just thinking back to myself as a high school student, which it feels shockingly recent, although it wasn't. I guess something else that I really felt was that in retrospect, there are a lot of disciplines that I didn't really know what they were. I didn't really know what engineering was. We didn't really have engineering in high school. So I feel like our high school curriculum really overemphasized the physical sciences, and the fact that there are all of these different flavors of engineering and what they consist of, what they depend on, I didn't really understand. The high school curriculum really overemphasizes calculus and de-emphasizes statistics. And, calculus is almost irrelevant in the work that most of us do in computer science today. I feel like statistics and kind of combinatorics are way more important than continuous math. And it feels very different to do that kind of math. I didn't really have a sense of what it was like. I've ended up working on economics a lot. My high school didn't have anything that looked at all like economics. I didn't really know what economics was. I thought it was sort of like accounting, really thinking about micro theories of human economic behavior and how they work and how they get validated and how you use data to train them. I just had no idea that people did this. I didn't really know what it looked like to do. I suspect high schools are maybe a little bit more savvy about the mathematical sciences now than they were when I was in high school. But I still think it's pretty laggy. Yeah. I have a theory, which might not be true, but it may be fun for your listeners. If you're a literature expert, it's pretty hard to get good jobs as a literature expert. There are just not that many jobs that will, give you a good living as a literature expert.
Mhm.
And so some fraction of literature experts are going to become high school teachers, and they're probably pretty good literature experts. If you understand how to reason about the economy using math, there are a lot of ways that you can make ridiculous amounts of money doing that.
Mhm.
So the people who teach that to high school students have been, economists would say adversely selected, right? The best people have been taken out of the pool by all of the other opportunities that they have. So, if you look at your teachers in high school, they're kind of systematically missing in the places that are the most useful in the economy, that have the most exciting other alternatives, which is kind of exactly the opposite of what you would like.
Mhm.
So it's kind of not it's not a coincidence that computer science, economics, business, engineering are kind of underrepresented in high schools, because those are such exciting fields. There's so many great things you can do. If you're skilled in those fields, you might be less likely to become a high school teacher.
I see. If it were up to you, what courses would you take out or would you make mandatory in high school?
I don't know about taking out. I think it's more a matter of tone, about what's sort of communicated that it's important.
Okay.
I think I would make statistics required and calculus optional. I think calculus was really exciting in the 1800s. I think it's less and less important now. I think calculus was a way of thinking about kind of dynamical systems, big complicated systems, and how to model things. But really, we model things today in Python. We don't model them in differential equations. So it's kind of weird that our curriculum hasn't caught up. We don't teach people that way.
Yeah, that's a lot of great insight. I definitely feel like high school definitely tries to teach you things that you don't really need in the future, which can be kind of annoying, especially.
In my high school, we had shop class. We had this like machine shop where you would like bend sheet metal and use a drill press. And like, this was teaching you how to sort of be a worker in the industrial economy of World War II.
I mean, yeah, we had mechanics. So there was auto and things like that. So something similar. We definitely have.
At least you got internal combustion engines. You're way ahead of me. Like we were.
Yeah.
But seriously, this just doesn't look like the jobs that most people are going to have. I think it's really kind of lagging, right? And you can imagine how this happened, right? You're in Ottawa, I think. So in Ontario, the auto industry is big. And at some point somebody said, wow, we should teach people this stuff. And kind of the world moved on substantially, but there's a lot of capital investment building a, auto mechanics shop in a high school. So once you've got it, you just kind of leave it there forever.
On to our next question. What does your day-to-day look like, and how has that been affected by the pandemic?
My day-to-day is really meeting people. There's a kind of, you guys are running a STEM podcast, so I imagine your audience thinks a lot about STEM. Maybe this wouldn't be surprising to them. A lot of people think that computer scientists kind of sit around alone and write code. I haven't written a line of code for like 20 years. I basically spend my entire day writing emails and meeting with people. And I work with sort of dozens to hundreds of people all around the world, and it's just hour by hour meetings. I had a Zoom account 3 or 4 years ago before the pandemic started, because I was just meeting with people all over the world all the time. So this has kind of accelerated something we were doing anyway. But science is so international that we were pretty used to all these tools before we needed them for the pandemic. But the average computer science paper has sort of between 2 and 5 authors, sometimes 20. So it's a big team of people working to build a big thing and then write an account together of what they did and sort of demonstrate that the thing that we built was good for something. And so it's really working in a big team. It's personality dynamics and trying to allocate tasks between each other. It's the sort of project courses that you will have done in high school are kind of an example of what I spend my whole day doing.
That's very interesting. Yeah, because I think I was definitely one of those people that had an impression that computer scientists just, I guess, sat around writing code all day. So that's really nice to know.
As you become expert at something, you start managing people who write code, right? Code isn't that hard to write. The hard thing about code is deciding which code to write. So the meetings are about like, what should the algorithm do? How should we analyze it? How would we know if this worked? How should we look for bugs? What should we compare to? Which strategy might work? The thing didn't work. What should we do next? So it's kind of talking about code. You wouldn't get anywhere if you didn't understand how to do it, but it's much more planning.
I see. So could you give us a just brief general overview of your career path beginning from high school?
Yeah, I grew up in Ontario. I went to high school in Richmond Hill, Ontario. Believe it or not, I was in the last year in Ontario where they still had grade 13, which was sort of awesome because we got to do lots of electives. I did 5 years of French and 5 years of band and, just tons of different electives that I wouldn't have had time for in 4 years. But for whatever reason, I did more high school than the average person. Then I went to McMaster. I did a major in computer science and a minor in philosophy. Had a great time, learning a little bit more about, what the people in high school hadn't understood enough to tell me. I learned that some of the math that I had learned was wrong, and some of the computer science that I learned, was much more. There was much more kind of fundamental, principled things that you could do. It was much less like hacking than I had originally understood. Then I went to grad school in California at Stanford and spent 5 years in Silicon Valley during the dot-com bubble. It was insane. I got my first startup job offer from somebody who was helping me move my boxes from my car to my apartment before I ever saw my apartment. And it wasn't because I was so amazing. It was just because Silicon Valley was so crazy that that kind of thing just happened all the time. It probably wasn't very sincere, but it was just like everyone was just going nuts, like starting companies. The joke was like people made a company to sell pet food on the internet. It's like, oh my God, 2 years later, then the whole thing crashed. Like, why did anyone think that made sense? And now, of course, you actually do buy pet food on the internet, and turns out they were just ahead of their time. But so that was amazing, going to a big American school that was really one of the international intellectual leaders in computer science. Was kind of a revelation. It was amazing to see. I have a fondness in my heart for McMaster, but it wasn't Stanford. It was a pretty different experience being at a top American school. And then I decided I couldn't stand living in the United States anymore. It was so I decided I was Canadian. I wanted to come back to Canada, but I kind of had gotten used to living near the Pacific Ocean and not getting cold every winter. So Vancouver seemed pretty good, and moved to UBC, and I've been here for almost 20 years.
Yeah, that's actually pretty amazing. Just something I thought I'd add about it not getting cold by the Pacific Ocean. It actually snowed here in Ottawa yesterday.
I saw in the news. I'm so sorry for you. I was like biking and wearing shorts yesterday.
You live in the dream.
It's pretty sweet in Vancouver. Everyone on your podcast should immediately move to Vancouver. It's just
okay. So now we're going to ask a few more career-specific questions. On your website or on the UBC website, it says that you've done a lot of work in algorithmic game theory. So can you just give us like a quick explanation of what exactly game theory is?
Sure. So I guess I mentioned before this idea that there's this thing called economics that when I was a high school student, I had no idea what it was. And for my past self, what I would have liked if somebody had told me is there's this sort of branch of math that tries to understand how people make decisions and how people behave in response to their own interests. And microeconomics is economics that has kind of people as the modeling unit. So it tries to think about how individual people act. And macroeconomics is kind of economics that has bigger, sort of more abstracted modeling units, like how does unemployment get affected by the interest rate or something like that. Never mind macroeconomics. Let's talk about microeconomics. Microeconomics is about things like how do people respond to prices? How, if you were a firm, how should you set a price to maximize your reward? Or if you're a country, how should you design a political system? How should you design voting so that good decisions will get made? Or how would you try to bring about some good social outcome like reducing carbon output if you care about doing minimal harm to your economy, but everybody's going to lie to you about how harmful it would be to them because they don't want to be the ones to reduce carbon, or stuff like questions like this. Many of these questions involve money, but money turns out to be a bit secondary. Money is really just kind of a way of taking people's interests and turning it into a number so that you can do math with it. I mean, you notice I gave an example about voting that doesn't really have money in it at all. Some people have some really beautiful, like economics without money has looked at how you can design kidney exchange systems to work better, where you're my brother and you need a kidney and I'm willing to donate a kidney, but you and I aren't a match. So we go to a hospital together and we say, Kevin will donate his kidney if you can find a kidney that is a match for Patrick. And if enough people in the world do this, you can find sort of a chain of people who can all make a match, and you can get more kidney more kidney transplanting happening. It's a real thing that was invented by computer scientists and economists working together that is based on ideas from economics without money. Anyway, so that's kind of what I wish I had understood about microeconomics. Turns out that around the time of the dot-com bubble, people figured out that microeconomics could learn a lot from computer science. So economics was just kind of happening in isolation by itself as sort of a very clubby discipline. And they were using a lot of calculus. They're using a lot of kind of traditional mathematical tools to answer the questions that they had. And there's some really beautiful math in economics, but at some point, some degree of complexity, it hits a wall. There are just questions they can't really come up with good answers to. And as computer science has gotten further, we've come to a point where we've realized some of these questions that we can't give beautiful closed form mathematical answers to in economics, we can address using computational techniques. And so this has become a really explosive area of growth in sort of the boundary between economics and computer science. Broadly speaking, this kind of field is called algorithmic game theory. And the reason why is algorithmic means computer science. It means, designing algorithms on a computer that would solve a problem. And game theory is the kind of mathematical tool that economists in microeconomics use to think about how to analyze human strategic behavior.
Okay, I see. So we saw on your website also that you were working in the field of AI and machine learning. So I was just wondering, is machine learning, does that relate to game theory? And if so, how exactly?
Sure. Well, so maybe I should say a little bit about what game theory is. Game theory really is a model that says individual people have their own interests. They have what game theorists call a utility function. So you live in some world where different things that can happen. You can take different kinds of actions, and as a result of the actions that you take and that I take and that Patrick takes, some state of the world comes about. Some outcome is realized, and then we all experience some utility for whatever happened. And game theory is all about, if the three of us are all taking actions at the same time in an uncoordinated way, but we all care about maximizing our own utility, what would happen? How are we each going to make decisions? So that's sort of fundamentally what game theory is about. It's for answering questions like that. Because if you want to do something like design an auction mechanism, you're sort of optimizing over auction mechanisms to find one that works well for whatever problem you have. And to decide for each design whether it works well, you need to have some way of predicting what people would do in that design. So game theory sort of supplies that piece of making a prediction. Machine learning is a different sort of technique for making predictions. Machine learning is basically an approach that takes past observations and uses algorithms to build models, to build predictors that can find patterns in the data that you showed it. For example, maybe I want to show you pictures of dogs and pictures of cats, and I want you to build me a dog-cat detector that can say whether a picture is a picture of a dog or a picture of a cat. That used to sound like a crazy, impossible science fiction problem when I was a PhD student. At this point, that's something that probably many of your listeners can, download some machine learning Python packages and run by themselves. So, using machine learning today, we can really do things like that just by showing the model examples. So game theory and machine learning kind of come together when I want to make predictions about how people are going to behave. And I don't just want to use mathematical assumptions like game theory does. Game theory says people will always do whatever is in their own best interest. That's a pretty good model, but it's not a perfect model. Sometimes people do dumb things. The dumb things that people do tend to follow patterns, right? That's why casinos make money. Like there are sort of fallacies in the way that people think that are reproducible. And if you really want to make predictions about how people will behave, game theory is a whole lot better than just making something up off the top of your head, but learning from data can get you further. And so a lot of my work has looked at kind of bringing ideas from machine learning into kind of game theory analysis.
So I'm sure you've done a lot of projects and such during your time. So what has been your favorite project to date?
You have so many children, it's hard to pick just one child who's your favorite. I'm sure your parents tell you the same thing. But they're lying. They probably have a favorite. But different projects I've liked in different ways. But I guess one project that's really close to my heart is a project called Kudu, which is an electronic market for agricultural commodities that we built for use by smallhold farmers in Uganda. And the idea is you're a farmer in Uganda, you have a mobile phone, which looks kind of like the mobile phone that I had when I was a PhD student. It's not a smartphone. It has number keys that you can press repeatedly to get letters, but it doesn't have a touch screen. And you can basically send the equivalent of SMS messages on it, but you can't, you can't sort of browse the web. And those kinds of phones are really, really widely available in Uganda. More people have phones like that in Uganda than have electricity, like by a pretty substantial margin. And before you ask, you might wonder to yourself, what do they do when their battery dies? There are actually like kiosks in the market. You can pay somebody to charge your phone. The question is, you've got people in Uganda living on less than $2 a day, growing food mostly to feed their family, but once or twice a year, they have some surplus produce that they want to sell. They're not very well connected to markets in their country. They don't have good knowledge about what prevailing prices are. They don't have longstanding relationships with agricultural traders. They tend to really get exploited. So we wanted to build a market that would help them to sell their crops in a way that would help them to get a fair price, and would help them to find a counterparty who wanted to buy from them. And we could do all of this at extremely low cost ourselves, because we were running as researchers and using the kind of low-end SMS mobile phones that people have. So long story short, we built such a system. It actually runs in Uganda for real money. It's done millions of dollars of agricultural trade. Millions isn't billions. It isn't the dominant way of trading agricultural staples in Uganda today, but it actually is used. And I think we learned a lot about what the real challenges are in the developing world. And I think just it was really an amazing experience working with collaborators in Uganda and coming to understand that environment. So that was a highlight.
That is a really, really cool project for sure. So was this something you did as part of your PhD, or is this after when you became a professor?
No, this is something I did as a professor. So something you probably know about professors is we get sabbaticals, right? Every 7 years, sabbatical comes from Sabbath, right? So the Sabbath is like every 7 days you're supposed to rest, and we get it on a yearly basis. So every 7 years you get a year off that you're supposed to focus on your research. I took a sabbatical and just went to Uganda. I just found somebody in Uganda who was kind of working on artificial intelligence and said, do you mind if I show up and, we try to work together? And he said, sure, come on down to Uganda. And so
Wow.
My partner and I went to Uganda. She was like, why not? Sounds like fun. We just started kind of talking about, what problems existed in Uganda that we thought AI could maybe help with. We ended up landing on this problem. So yeah, it's just something I've done as a researcher.
Wow, that really does sound like an amazing experience. So are there any particular projects or events that you are looking forward to in the future?
No, I think at this point, my life is just a boring, sad drudgery towards the future. You were supposed to laugh. Oh my God, you're like, oh, this is so sad. The podcast is taking a terrible turn. I don't know. What am I excited about in the future? I think I'm excited kind of broadly just about the direction that AI is taking. I think the last 2 or 3 years have been really explosive years in AI for problems that looked like they might take decades to solve have suddenly started to fall. Image recognition, language recognition. People are really making crazy progress. And it's just a really exciting time to be a researcher in this field. There's just so much going on. I think natural language processing is probably the most exciting subfield of AI, in my opinion, right now. I don't know if you know about these GPT-3 language models. So maybe you've seen this like science fiction trope that, you have the computer and then it you teach it a bunch of stuff. And then one day it kind of goes to the library and it reads all the books in the library and then it kind of becomes smart. And then you sort of, AI becomes like a boy who can truly love. There's a bunch of parts of that story that are not realistic, but GPT-3 is a reasonable approximation of that. So except, it didn't become conscious and it can't truly love. But they basically found a way of taking a machine learning model and training it on all of the text on the internet. So the really tricky thing about training a model is you need labels. I gave you the dog-cat machine learning example. Notice something that was really important there is I need a person to tell me that's a picture of a dog and that's a picture of a cat. And so inevitably, my ability to do machine learning at scale depends on my ability to come up with what we would call labeled examples, right? Somebody who can tell me about dog pictures and cat pictures and tell them apart. And then at some point, machine learning can find the pattern, but the pattern needed to be there in the labels. So it's pretty hard to just say, go read all of the text on the internet and figure it out. That seems sort of underspecified. We don't really have a way of turning that into a mathematical optimization problem. So the really brilliant idea that people had was to do masking in language. So basically the idea is to say, I'm going to show you some text and then I'm going to ask you to predict something. And there's kind of two approaches that people use right now. One is I just cover up 20% of the words in the text at random. And I say, look at the rest of the text and see if you can figure out what the masked words were. And I'll reward you based on how right you are. The other approach people use is I just show you the text sequentially and I keep asking you to predict the next word. They're more or less equivalent. GPT-3 does the second version. So if you think about it, you have to learn a lot about the world to be able to get that right. A lot of like multiple choice tests, a lot of common sense knowledge, a lot of it isn't all just like New York blank, the answer is probably city. Like, some of it is like really low level stuff. But some of it is, much more complicated. Like, you can phrase some puzzle and then, the answer to the puzzle is the missing word. Or you could have some, which is bigger, a dog or a cat, a dog, like there's lots of places where you could sort of find examples in language where something really surprising, you really need to understand a lot about the world would be required to be able to do this kind of completion very accurately. And basically people have started training ridiculously big models, sort of trillion parameter models, on basically all of the text on the internet, using supercomputers that cost literally millions of dollars of electricity just to train the model and take something like a year to train the model. And they're producing these language models that can like write poetry and take the SAT and like translate one language to another language and just like do completely ridiculous things. So if you haven't heard about this, I encourage you to just like Google GPT-3, see some examples about what it's doing. But most people don't know about this. This came out like less than a year ago, and it just keeps getting better sort of month by month. People are making kind of incremental breakthroughs in this space. So, I think we're getting pretty close to the point where you can say like, hey, Siri, give me 500 words on, the fall of Rome, and, it can write you an essay.
Wow. Yeah. I mean, you did an excellent job of explaining it, but I definitely will do some more research, and I would definitely encourage our listeners to go and do research as well, because it sounds like something that is pretty incredible and something that's really big coming up.
Yeah, I also, it's definitely really incredible how the pace at which technology is advancing. And I think it'll be really interesting to see where it's at by the time our generation gets to like be part of the workforce. All right. So that's pretty much all we had to touch on regarding career specific stuff. So I guess now we'll move on to the more general questions. So what is one obstacle you've had to overcome during your career, and how did you deal with that?
I mean, it's sort of hard to answer because I feel like having a career is just the constant experience of obstacles. It's sort of hard to pick really one. I guess I would say something that has become increasingly clear to me, and I think most PhD students kind of learn as PhD students, and you have to really understand if you want to be an advisor of PhD students, as I now am, is that most obstacles are really kind of psychological. Being good at computer science or engineering or math is, a little bit about how good you are at computer science or engineering or math, but a lot of it is sort of how you can manage your emotions, how you can work with people, what you feel insecure about, what you feel avoidant about, and how you can make yourself do things that you're feeling avoidant about. Sort of how do you manage yourself? How do you reward yourself? Just, really confronting your own psychology and learning how to get over your own stumbling blocks, learning how to sort of get past feelings of shame and inadequacy and, these kinds of sort of dark emotions that keep you from taking risks. I think is a really fundamental part of what it takes to be successful in research.
So it definitely sounds like learning habits are a very important role when, I guess, being successful in one's career. Would you say that that is accurate?
I would, but I guess I would say it isn't really one size fits all. I think it's really listening to yourself and really just kind of taking the time to figure out, when you're stuck on something, like what feeling are you having? What fear do you have? What aversion do you have? What is it that you dislike? And trying to learn how, in the one case to figure out, I just don't enjoy this kind of thing. I want to not do it. I want to find, a career that's not going to ask me to do this thing I don't enjoy. Or on the other hand, figuring out this is something I really need to be able to do. It's stupid that I can't make myself sit down and answer my emails or write a page of text or read a book or whatever it is that you might get hung up on. And not to just kind of bludgeon yourself by saying, I need better learning habits, I need better hygiene, I need to just pull my socks up. More like I need to really figure out, why am I not doing this? Why is it so hard for me? Why can I read Twitter for 4 hours, but then I can't read my assigned reading for 15 minutes? What is it that feels different about that? And I think you can actually get to the bottom of it. It is really something that you can make progress on by understanding. I think that sort of gradual process of trying to figure that out about myself has been, when you sort of think about surmounting challenges in one's career, I think that's really been, what I think of when you say that.
For sure. I think a lot of high school students, myself included, I would say, have a lot of trouble picking a career right now. And I remember something you said was that it is very important to just sometimes realize that maybe halfway through your career, halfway through your course or whatever it is, that you just don't enjoy the topic that you're learning. And I think a lot of people have a very hard time to grasp that because they feel like they need to make one perfect decision, like that life is linear, which it obviously isn't. So just to wrap things up, what is one piece of advice that you would give to your younger high school self?
I guess I want to answer a different question. I'll see if I can come up with an answer to your question.
Yeah, for sure.
I feel like something that in retrospect, I really did right as a high school student that I didn't know was right at the time, but in retrospect, I think was great. Something I sort of want to commend my high school self for. I was really not that concerned about grades, and I really made most of my decisions based on what I enjoyed. I really sort of tried to have fun intellectually rather than trying to get to some goal that I thought I was supposed to get to. For whatever reason, I had parents that didn't pressure me very much to choose one thing over another. If anything, they thought STEM was a waste of my time and I shouldn't be doing it. That's probably changed. But I just really did what I sort of thought was fun to do and what I found rewarding to do. And when I'm reading applications for graduate students who want to work in a hot field, and we admit maybe a couple of % of the students who apply to us. It's just insane, like how competitive it is. Really what we're looking for is people who are just enthusiastic for their own sake. They're really doing something they love doing. And, you can't fake it. We're not looking for people who say they love doing it. We're looking for what it really actually looks like to love doing it because we love doing it and we know what it looks like. And so, as a high school student, I think you're going to be better at the thing you love doing than you are at the thing that your parents told you to do. So you might as well do the thing you're going to be better at. You're going to think about it in the shower and while you're walking your dog and, while you're eating your Cheerios. You're just going to mull it over and, you're going to have the passion project where you just sort of try something out because you want to see what happens, and you're going to read newspaper articles about it and mull it over. And, that just adds up over time to such a competitive edge. So finding a way that work can feel like play rather than feeling like something you're being made to do is just so important. And I think it's really sad to me, the pressure that high school students are evidently under to get good grades now. I think it's really a shame. I think to some extent you do have to play that game, but most high school students that I know worry more about grades than they should. I think in the end, if you get really good at something and really enjoy it, the grades take care of themselves. You get the letter of reference from the summer project by somebody who's blown away by you, or you build the app that people use, or you volunteer somewhere and that turns into a job. Like, these other sorts of more informal paths are really the way most careers actually happen. So I think, I guess I would have liked it if my past self had better understood that.
All right. So that was our last question. So we just want to thank you so much for joining us today. That was a really incredible and insightful conversation. And we hope that you and the rest of our listeners have a great rest of the day.
Thanks a lot. It's been fun talking to you.